What do people mean by a data center in space, and why is it suddenly being discussed now?
It means putting computing and storage hardware in orbit, then linking it to Earth via satellite communications. It's being revisited because launch is cheaper, on-orbit hardware is improving, and demand for compute and AI is rising faster than power and cooling on Earth.
What real problems could space-based data centers help with, if any?
In theory, they could ease cooling constraints by radiating heat to space, tap continuous solar power in some orbits, support coverage where connectivity is sparse, and handle certain niche low-latency links to satellites, though for most users, Earth latency would still be dominated by the space link.
If we tried to build one, what would the basic architecture look like?
You'd choose an orbit based on coverage and radiation trade-offs, power it with solar arrays and batteries, dump heat through large radiators, connect via optical or RF links to ground stations and other satellites, and design the compute as modular, swappable units so capacity can grow incrementally.
What are the biggest constraints and risks that could make space data centers impractical?
Launch and integration costs remain high, maintenance is difficult, radiation can corrupt data and damage chips, debris increases collision risk, cybersecurity extends to ground stations and links, regulations around spectrum and operations are complex, and end-of-life disposal must prevent adding to space junk.
Economically, where could space compute make sense first, and where is it unlikely to compete?
It could make sense for processing data already in space, like Earth observation pipelines, or for edge caching and routing within satellite networks, plus specialized defense or scientific workloads. It's unlikely to beat terrestrial clouds for mainstream web and enterprise apps because bandwidth, latency, and operational costs are hard to match.
Who are the innovators pushing this forward, and what parts of the stack are they tackling?
It's a mix. Startups proposing orbital compute platforms, satellite operators adding on-orbit processing, launch providers lowering delivery cost, aerospace primes building hardened hardware, and space agencies funding demos. The enabling ecosystem includes optical links, radiation-tolerant chips, robotics, and standardized satellite buses.
So what's the balanced verdict, and what would a realistic roadmap look like?
A realistic view is that space data centers could succeed in narrow, high-value niches, especially processing data already in orbit. The likely path is demo payloads, then modular clusters with robust comms and thermal systems, and finally specialized services integrated into satellite networks, while most general-purpose cloud computing stays on Earth.